Hello calculus students, this is Mr. Bean. Welcome back to our very final unit in calculus. We're going to have just about 4 more lessons and then we are all done. This is so exciting. In today's lesson we're going to talk about area between two curves. This is actually pretty nice and simple compared to some of the things we've been doing in the past. I think you'll enjoy this. So let's start off by remembering how we find the area under a curve. If we just have some curve, sketch this parabola here, if you can do that on your notes. If we're trying to find the area under the curve, pretty basic stuff. All we would do is, don't shade, just draw the parabola, do not shade what I'm doing. But we would just take the area under the curve up to the x-axis. So between the curve and the x-axis, and that's it. That's what we would do. Well, what if we're trying to find the area that's in between two curves? This little part right here, well, go ahead and draw this square root graph. So we have a parabola, draw the red square root graph. Don't do what I'm doing right now, and that is shading everything that's underneath the square root graph. Okay, so if I were to do all of that, now, if I was trying to just find this part up here, and only this part, what's in white, between the blue and the red line, I would need to think, okay, go back to my blue. I would want to think, here's my area of blue, here's my area of red. If I found all the area of blue and subtracted the area of red from the same interval, okay, so I focus in on the blue, then I would have, what I'd have left is just this piece right here. Okay, so that's what we're going to set up. In other words, if we take, let's get rid of this part here. If you take what's in blue, f of x, the function that is larger, has larger y values, and you subtract the function that is smaller, has smaller y values, you get what's in between the two curves. So this only works, of course, if f of x is greater than g of x. That's the important part here. And that's it. That's basically the entire lesson right there in only 2 minutes, or however long this just took. So we're going to just do some practice problems with this. Obviously, there's more to it than just this. There's some little bit more challenging things that we have to figure out, but this is the gist of what we're doing for this whole lesson. So pause if you don't have all that written down, and let's move on. So here's our first example. We're going to find the area bounded by the curves x squared plus 2, y equals negative x equals 0, and x equals 1. So I've already given you the graphs of the first two here, x squared plus 2, and then y equals negative x. Let's draw in x equals 0, so we're right here, and then x equals 1 is a vertical line like this. So there's our vertical line going off forever and ever. And we're trying to shade the area that's bounded by all of those things. And so that is, let's get my crayon here, that is this area right here. So if you want to try and shade that in, you will not always have a visual representation of the graphs. We're going to start off with the first few where we can see what's going on. Sometimes you'll just have the equations and you got to go from there. But for these, we're going to start off pretty simple. So what is the area bounded by these curves? It is, we're going to go our integral from our lowest x value to our highest x value of the area. So our lowest x value is a 0, our highest x value is a 1. And then which function has larger y values? Which one's the one on top? It's this parabola. So I'm going to say x squared plus 2, close my parentheses. Then I'm going to subtract the other function, the one that's below it, which is just the function negative x. Not x, negative x, right? Yeah. And then that is all with respect to x. What's nice about this is it does not matter that this area is negative. It's not going to matter because we just take the one that's on top and subtract the one that's in bottom, and you ignore whether or not it's above or below the x-axis. That makes this really easy compared to some of the things we've had to do before. So let's finish this off. So 0 to 1, this now becomes x squared. This is plus x plus 2. Oops, there we go, with respect to x. And now take the antiderivative. I should probably be writing a little bit smaller because you're probably completely running out of room on yours. X cubed
plus, over 3 plus x squared over 2 plus 2x. And we're going to integrate this between 0 and 1. So we'll plug in the 1 and then plug in the 0. Well, if we plug in the 0, it's just 0, 0, 0. So that's easy. All we really need to do is plug in the 1. So I'm going to move this over here because I'm running out of room. We have 1/3 plus 1/2 plus 2. Get common denominators, add all that stuff up together, and you would magically come up with
17/6. Okay, I got common denominators added together. I already did this work in advance, so we didn't have to take time adding fractions in the lesson. 17/6, that is the area of this thing. And now if I had any particular units, I'm going to write this down, but you don't have to normally unless it's specifically talking about something with units. But it would be units squared because this represents an area. All right, there's my answer. Again, you don't need to always write units squared. It's just I wanted to point out that this is area. Okay, let's go on to another example here, and that is find the area bounded by this thing and this thing. Notice now I don't give you a graph, so let's sketch our own graph. Maybe way off on the left side in the margin of your notes, then draw this. I'm going to draw it way down here. So I have, just do a quick little x, y grid. And 2 minus x squared is a parabola that opens down. So, and this is literally what I mean by sketch. It's just really fast. 2 minus x squared. Y equals x is a diagonal line like this with a slope of 1. And so then I'm looking for the area. I'm going to color this in red so you can tell. This is the area that we are looking for right here that's bounded by these two graphs. So it's easy to tell which one's on top here. The one that has larger y values is the parabola, 2 minus x squared. That helps us set up our area. So we're going to go from, oh, now here's the question. What are the boundaries? Oh, we don't know. I didn't give it to us in this problem. So how do you figure out this point and this point? It's when the two graphs cross or intersect. That means, let's go over here on the right side, 2 minus x squared is going to equal x. It's when these two functions equal each other. How do we solve this? We get everything onto one side. So let's set it equal to 0. I'm going to bring everything over here to the right side because it'll make this x squared positive. X squared plus x minus 2. And then we factor this thing. We'll get x plus 2 and x minus 1. And then that leaves us with an x equals negative 2 and an x equals 1. These are the two x values where it crosses there and there. So an x value of negative 2 to an x value of 1. Those are my boundaries from negative 2 to 1. Okay, so if you don't have the picture, sketch a quick little graph if you're able to, or if you have to grab your graphing calculator, that might help you so you can visualize it, and then you're plugging in these points. Okay, let's see, which one goes first? 2 minus x squared minus the second function, the one that's underneath, is x, and then that's all with respect to x. Okay, what's next? We could clean this up and say 2 minus x squared minus x, but that's not really going to do anything. Let's just take the integral right off the bat here.
We're going to have 2x minus x cubed over 3 minus x squared divided by 2. I add 1, divide by that number, and then we're integrating between negative 2 and 1, so we'll plug in the 1 first, then plug in the negative 2. So many fractions. Okay, plug in the 1. We get 2 times 1 minus 1/3 minus 1/2. Okay, so that was just the 1 plugged in. Minus, now be careful, remember, this is where you guys make mistakes a lot of times. We have students all the time forget this minus. That has to go to the whole thing. So now we'll plug in the negative 2. So this becomes negative 4. Again, I'm plugging this negative 2 into each of the x's. Negative cubed is going to be another negative, so that's going to be plus 2 cubed is 8. 8/3. And then a negative 2 squared makes it positive, so it's just minus 4 over 2. Close my parentheses.
And now we can work with fractions and do all that hard work, and eventually you'd come up with that this is 9/2. So this area in red down here, that whole area represents 9 over 2, or 4.5 if you prefer decimals. Okay, that's how we do that. Now, if you didn't have this picture, you would be able to figure out between negative 2 and 1 which one was larger. Like if I said, okay, what's an x value that's in between negative 2 and 1? 0 is in between negative 2 and 1. If I plug a 0 into this one, I'd get a 2. If I plug a 0 into this one, I get 0. So see, this one would give me a 2. This one, if I plug in a 0, would give me a 0. So which one's larger? This one is. So you don't even need the picture if you plug in a number that's within the boundary on that interval, and then you'll know which one is larger. All right, number 3, I give you here 2 graphs only, but the key is that I do mention right here the first quadrant. So the first quadrant helps us understand that we're going to be having a boundary line right here within the x. So let's just draw the picture of what we're trying to do. This is a little tricky. Woo, what are we doing here? Y equals the square root of x and x minus 6. So if we want all of this area right here, going up and down, between these graphs and within the first quadrant. So this is everything that we want. We actually have to get two separate areas that we have to look at. So in other words, let me erase part of this and you'll see what I mean. So I'm going to do this in a different color. So from here, this is the key is x equals 6. Now we're going to find two different integrals. So we'll set up two different integrals. We first want one for the red area, and then we want one for the blue area. So the red area, this one's really easy because it's just a square root graph. We're going to do the square root and everything between it and the x-axis. So that is from 0 to 6. From 0 to 6, we're doing the square root of x with respect to x. All right, next, we're going to add the blue area. So I'm going to do the integral from, the blue area goes from 6 to 9. If you didn't know for sure where this crosses right here, then you can take the square root of x. I'll show you this over here real quick. Square root of x equals x minus 6. And then you would solve this. If you didn't have a calculator, it's actually not as bad as you first think. You square both sides. So this would become x equals x minus 6 squared, which means x minus 6 times x minus 6. And then you could get x equals x squared minus 12x plus 36. You bring the x over here, set it equal to 0. You get x squared minus 13x plus 36. You factor this and solve, and you're going to get two answers, x equals 4 and x equals 9. Well, that's kind of weird. Why do we have two answers when it's only x equals 9? So I'm going to go from 6 to 9. Okay, but where does 4 come in? This is actually what's called extraneous solution. We don't count it because if you plug it back up in here, 4 minus 6 is negative 2. It wouldn't equal it. So this one's extraneous. That's why this is the only one. Okay, so that's kind of separate from this lesson. It was just some algebra skills of how to set these equal to and solve, but it might have been a helpful reminder. Okay, let's keep going. So the blue area, we're going to go from 6 to 9, but now I can't just do the square root of x because that would include everything underneath this line as well. I don't want that. So I want to take, in fact, if I put that back, I want to take the square root right here, the square root of x, and subtract this here in black, the area that's underneath that line, which means I'm taking the integral of that x minus 6 with respect to x. And that will give me the red. That's the red portion. And this is the blue area right here. There's the two things put together. That is the integral setup. Notice the directions. It doesn't say we have to solve it, so read your directions carefully. Sometimes it just says set up the integral, and we are done with this one. Okay? Yeah, because there's nothing that simplifies. Oh, I guess technically I could go distribute, and make it minus x plus 6, but you get the idea. This is how we set that up. Okay, this one here, this one's exciting. We've got this craziness going on. Set up the integrals to find the area. Yes, we're not actually going to find the area. We're just going to set up the integrals. That's so nice because it makes it easier for us just setting this up. Oh boy, well what's going to happen here is we need to figure out first where these two things cross. I could plug them in a calculator and see what it looks like, but let's just do this by hand first. So I'm going to take let's switch colors. 3x cubed minus x squared minus 10x, and that's going to equal negative x squared plus 2x. Now, how do I solve something like this? Set it equal to 0, and then let's see what we have from there. Hopefully we can factor or quadratic formula it or something. Let's see. I'm going to go 3x cubed, add x squared, and that cancels. So those two things, when I add the x squared, those two things are going to cancel. And then I subtract a 2x and I get a minus 12x equals 0. In fact, if you're not doing this, hopefully you can write smaller than me. It's hard with this pen. And let's move this stuff over here to the right a little bit more. Probably should have told you that already before you started, because we're going to need more room on the left. Factor out what they have in common. I get a 3x times x squared minus 4 equals 0. And then this factors down even more, or I could just solve it and get plus or minus 2, x squared minus 4, and solve it. But it's the difference of squares. Let's just go ahead and show you what I'm doing. Okay, so I have x equals 0, x equals 2, x equals negative 2. This thing crosses 3 times. What in the world is going on? Well, here's what we'll do to set things up. We're going to do this. we're going to say the integral of 0, no, not 0, the smallest x value is a negative 2. So we got to start off with negative 2 to 0. And then I'm going to have either the f of x or g of x. Which one goes first within that interval? Let's try it out. Let's plug in a negative 1. Let's just do a test point. If x equals negative 1, so let's see here, f of negative 1 and g of negative 1. Let's test those out and see what we get. So f of negative 1, that is negative 3 minus a 1 plus a 10. So that's going to be 6. If I plug it in this one, negative 1 is going to be squared, but then a negative minus 2, that's negative 3. So which one's larger? The 6. So I'm going to have, let's erase some of this. I'm going to have the function f is larger. So f is going to come first. F of x minus g of x with respect to x. And then I'm going to add, what's my next interval? Now I'm going to go from 0 to 2. 0 to 2. And what is that going to be? Oh, I just need, it's probably going to be the other way around, but let's just double check just to make sure. So I'm going to plug in a number in between this interval 0 to 2. So let's test f of 1, positive 1 this time, and g of 1, and see what I get. F of 1 here is going to be 3 minus 1 minus 10. Did I do that right? 3 minus 1 minus 10. Yeah. So 2, negative 8. And g of 1. So I'm going to have negative 1 plus 2 is a positive 1. All right, so the g is larger. So I'm going to say g of x minus f of x with respect to x. Okay, so this is set up. And we could just set this up just like this, but we probably are supposed to clean this up a little bit. But I want to show you what is happening. I'm going to copy this to the next page so you can see it. Okay, this is the graph of what's happening. So you can see this part right here in red, that's from negative 2 to 0. That's this. That's what's being bounded right here. And then we're adding, this part is the blue part. We're adding this one. And those are the only two regions that are bounded, because after that you can see it goes up forever and ever, and this one's going to go down for quite a ways. And so this is just the areas that are bounded, and that's our setup. So again, we would take this polynomial and subtract that polynomial, and you can combine like terms. I'm not going to worry about that in this part of the lesson. It's more of understanding how to set these up. Okay, the very last one. I cannot overemphasize how important this problem is. If you are not listening and you're just reading the words, stop it. Listen to what I'm saying right now, okay? This is important. So far, we've been integrating with respect to x. In this example, we're going to integrate with respect to y. Oh, yeah, this is weird. So here's the reason why. If we integrate this with respect to x, which we could do, it's kind of a pain because look what would happen. We'd have to find the area up to this point right here. Okay, you see that? You would take this function, whatever that line is, and subtract this one. But you'd have to solve for y on both of them. So you'd solve for y, solve for y. And then you would take a different integral and subtract this one right here. You'd take this function and subtract it from this function after you solve for y. So it's possible, it's doable, but sometimes it's just easier to not do it with respect to x. And when I say respect to x, it's like this, where I'm doing up and down lines perpendicular to the x-axis. So I'm just going up and down, up and down, up and down. That's how I'm integrating with respect to x. So let's do it the other way. Respect to y. It's almost like if you turned your head sideways. I know you can't see me, but I'm turning my head sideways right now. And I'm starting at the low value of y, and I'm working my way up, going this way. So I'm going perpendicular. You might want to write that down. Perpendicular to the y-axis. That's the way we're integrating. It's this way, perpendicular to the y-axis. We start on the bottom, the smallest y value, and work our way up. All right, let's do it. So integrating from what is the smallest y value right here, and then we're going to go to the largest y value right there. The smallest y value is -2. Yes, we could set these things equal to each other and solve, but this picture is helping us know right off the bat what it is. And then the largest y value right there is a 1. So I'm going to integrate from -2 to 1. Now I need to do the largest function first. Well, not really function, the largest equation first. Since I'm doing with respect to y, you have to think the largest one is the biggest x value. See, before we were doing biggest y value on previous problems. Now, which is the furthest one out? It's this weird looking parabola thing. So that is 3, let's put parentheses here, 3 minus y squared. And then I subtract the smaller equation, the one that has smaller x values on this interval, and that's this line, which is the y plus 1. With respect to y. This is the integral. So now that, if I clean this up just a little bit, -2 to 1, let's see, I'm going to have negative y squared minus y, and then I have 3 minus 1, that's going to be a plus 2 with respect to y. There's my answer for this problem. Okay, that might have seemed pretty easy, but it is for some of you, but this is a little tricky, and this is going to come back up in a lot of the lessons that we do throughout this unit, where we have to do it with respect to y going perpendicular to the y-axis. So you start lowest y value to highest y value. All right, and in fact, on some of the practice, I'm going to make you do both, where you have to do it with respect to x and with respect to y, and you find it and see that they're going to be exactly the same answer. All right, that is the end of this lesson. This is Mr. Bean signing off. Rock that mastery check, and I'll see you back in the next lesson.